pH adjustment systems. One of the most common treatment processes of industrial wastewater is pH adjustment. pH is a measure of the degree of acidity and basicity of a solution, specifically, the measurement negative logarithm of the hydrogen ion concentration. The term pH refers to pondus hydrogeny, or power of hydrogen. Industrial wastewater often contains acidic or alkaline constituents that require neutralization. Neutralization of wastewater that is highly acidic, wastewater with a low pH, or highly basic wastewater with a high pH, is required for discharge to municipal sewer systems or to rivers and to streams. The allowable pH range for discharge is generally 6 to 9 standard units, but can be 5 to 11 standard units depending on the source of discharge and the receiving body. There are 4 main reasons to control the pH in wastewater. First is to protect human health and the environment, fish and other living organisms in rivers and streams. The concentration range that is suitable for the existence of most biological life is quite narrow. The second is to protect the wastewater infrastructure from corrosion, especially from acidic wastewater. Protection of the biological treatment processes that are employed at most publicly owned treatment works is another reason for pH adjustment. Lastly, many pretreatment systems require that the pH be adjusted as an initial step in the treatment process, such as coagulation and flocculation processes for the removal of oil and grease, phosphates and suspended solids, and precipitation of metals in the metals removal treatment process. These further treatment processes are very pH dependent. Neutralization can be accomplished by batch treatment or continuous flow. Batch treatment is usually for lower flow volumes. Most systems are continuous flow type systems consisting of 1 or 2 neutralization tanks, depending on the flow rate and magnitude of pH swings. With some systems, the pH must be raised or lowered for the downstream processes to function properly, and then the pH must again be adjusted prior to discharge. pH adjustment can be one of the most difficult chemical reactions to control. pH is measured on a logarithmic scale, which means that small increments of change on the pH scale is a 10-fold change in the hydrogen ion concentration. Heavily buffered wastewaters can exacerbate the difficulty. CWS has extensive experience in pH adjustment on a wide variety of wastewaters. CWS has the facilities to conduct bench-scale testing in-house. Let our experience work for you. Metals finishing wastewater. The metal finishing industry covers a broad range of manufacturing processes and is the largest group of industries regulated by the U.S. Environmental Protection Agency. Processed wastewater from the metal finishing industry may include high levels of heavy metals such as chromium and zinc, which are detrimental to municipal treatment systems and receiving streams. Therefore, they must be removed before discharging. Complete Water Services has designed and installed award-winning systems for pretreatment of metals finishing wastewater. CWS applies proven technologies customized for each individual system. There is no one-size-fits-all equipment or treatment process. However, there are some common unit processes for metals removal. The major components of a metal finishing treatment system include equalization, pH adjustment, precipitation, coagulation, flocculation, clarification, and sludge dewatering. Equalization is a means of buffering the varying characteristics of wastewater prior to entering the treatment system. Equalization minimizes the impact of fluctuations on downstream processes. Benefits include a reduction in treatment chemical costs, smaller downstream treatment components, and easier operation of the pre-treatment system. Most equalization systems consist of a tank that is mixed to keep solids from settling or aerated to keep the waste from becoming septic. Due to the nature of the metal finishing industry, pH of the wastewater is extremely variable and must be adjusted for metals removal. pH is a measure of the degree of acidity and basicity of a solution and is extremely critical in the metals treatment process. Precipitation is a chemical reaction that converts soluble metals into a solid and occurs at specific pH levels. The solids formed by precipitation are very small and must be further treated for removal. Coagulation and flocculation processes chemically convert colloidal solids into larger solids. Colloidal solids are very small, finely dispersed solids that remain in suspension. Coagulation is the process of adding a chemical coagulant that causes the clumping together of the very fine particles into larger particles called pin floc. Flocculation is the process of adding a chemical flocculant that causes the pin floc to agglomerate into larger solids for removal by clarification. Coagulation and flocculation will not occur if the pH is outside of established ranges. Clarification is the separation of solids from wastewater using gravity. The process usually incorporates a clarifier that holds the water or wastewater for a set period of time to allow the solids to settle to the bottom. Clarifiers have sloped bottoms to concentrate the settled solids. The solids can then be pumped to sludge holding tanks for further treatment. Clarifiers used in many industrial applications include inclined plate packs that enhance settling. Inclined plate clarifiers work very well for metal finishing wastewater. Measuring flow is one of the most important functions in water treatment. Flow measuring incorporates a weir or flume and a flow meter. The flow meter measures the change in the liquid level and converts the change into a flow measurement. Dewatering is a sludge thickening process. After clarification, the sludge is primarily 98% water and 2% solids. To reduce sludge disposal costs, further dewatering is required. The most common dewatering device with metal finishing wastewater is the plate and frame filter press. Sludge is pumped from the holding tank to a conditioning tank where it is mixed with a filtering aid to improve dewatering. Then the sludge is pumped to the filter press where the water phase passes through the filter cloths while the solids are retained within each plate chamber. Once the cycle is completed, the filter cake is deposited into a drum, cart, or roll-off for proper disposal. Primary DAF with biological secondary DAF. With this type system, dissolved air flotation is used for secondary solids clarification in a biological treatment process. The mixture of solids in the form of biomass and treated wastewater flow from the bioreactor to a DAF unit for solids clarification. The DAF is designed for separating the biomass from the water by flotation rather than settling, as with a conventional type clarifier, which relies on the limiting factor of gravity separation. Therefore, unlike conventional clarification, a DAF can even provide separation when the biological system is in upset conditions. Equalization is a means of buffering the varying characteristics of wastewater prior to entering the treatment system. Equalization minimizes the impact of fluctuations on downstream processes and is especially beneficial to biological treatment systems. Since biological organisms can tolerate only a very narrow pH range, wastewater pH must be adjusted to maintain the viability of the activated sludge process. pH is a measure of the degree of acidity and basicity of a solution and is extremely critical in biological processes. Fats, oils, greases, and suspended solids are often removed prior to the bioreactor to reduce loading on the system. Dissolved air flotation is frequently used up front for removing these types of solids. Coagulation and flocculation processes prior to the DAF chemically convert colloidal solids into larger solids so that they are more easily removed in the DAF. This type of system is referred to as a primary DAF system. A secondary DAF system, used to separate the biomass from the treated wastewater, is much more efficient, occupies a smaller footprint, and can run a higher concentration of biomass than a conventional system. The skimmings, or DAF float, are either returned to bioreactor to maintain the mixed liquor concentration or sent to sludge handling as waste sludge. Complete Water Services has designed and installed many primary and secondary DAF systems for a variety of wastewaters. In some cases, only one DAF unit is installed to function as both the primary and secondary DAF by alternating the influent to the DAF. Using primary and secondary DAFs provides an extremely robust treatment system. Membrane Bioreactor System. The membrane bioreactor, or MBR, is the most advanced technology with respect to biological wastewater treatment. The MBR uses ultrafiltration membranes for separating the biomass from the treated wastewater. The quality of treated wastewater from the MBR process is unsurpassed by any other commonly used technology. MBRs are very effective in the reduction of biochemical oxygen demand, or BOD, by biological degradation using activated sludge. Industries such as food processing, specialty chemicals, pharmaceuticals, etc., generate wastewater that is high in BOD. In industrial settings, real estate is a pricey commodity. MBRs offer high treatment capabilities with a smaller footprint. Equalization is a means of buffering the varying characteristics of wastewater prior to entering the treatment system. Equalization minimizes the impact of fluctuations on downstream processes and is especially beneficial to biological treatment systems. For MBRs, upstream pretreatment processes are critical. Since biological organisms can tolerate only a very narrow pH range, wastewater pH must be adjusted to maintain the viability of the activated sludge process. pH is a measure of the degree of acidity and basicity of a solution and is extremely critical in biological processes. Fats, oils, greases, and suspended solids are often removed prior to the MBR to reduce loading on the system. Dissolved air flotation is frequently used up front of an MBR to remove oils and other suspended solids. Coagulation and flocculation processes prior to the DAF chemically convert colloidal solids into larger solids so that they are more easily removed in the DAF. Because the MBR uses ultrafiltration to separate the biomass from the treated wastewater, much higher concentrations of mixed liquor suspended solids, or biomass, can be maintained in the bioreactor, thus reducing the tank size required. Ultrafiltration membranes in MBR systems typically use a 0.03 micron pore size, which removes virtually all of the suspended solids as concentrate. This concentrate is either returned to bioreactor to maintain the mixed liquor concentration or sent to sludge handling as waste sludge. Treated wastewater is the permeate from the ultrafilter. A well-designed and operated MBR system can achieve wastewater reuse standards for process applications and provide significant opportunities for industrial wastewater recycling. Complete Water Services has designed and installed award-winning MBR systems, both with and without water recycling and reuse. Large systems or small, CWS has the experience to evaluate the viability of an MBR system to your specific treatment scenario. Water recycle, reuse. With the increasing demand for fresh water caused by population growth and drought conditions in many areas, the emphasis for water recycling and reuse has significantly increased. Recycling and reusing water is a great step toward a company becoming greener. Whether the water is recovered condensate or processed wastewater, technologies are available to increase the quality of water to any level required. Systems can be permanently installed, skid-mounted, or temporary. Establishing a water reuse program is a means of providing a drought-proof, renewable supply of water. In many cases, implementing a reuse program can be an economical way of meeting increasingly stringent wastewater discharge requirements. CWS can design and develop your system tailored for your specific needs. Systems are based on the type and specific characteristics of the source water and the unique water quality necessary for the destination water. Common internal water sources that benefit from recycling include cooling tower blowdown water, boiler blowdown water, condensate water, equipment heat exchanger cooling water, reject water, process unit wastewater, wash and rinse water, scrubber water, industrial wastewater effluent, storm water runoff. Many companies are establishing water reuse programs to reduce costs and to lower their overall water footprint as part of sustainability policies and to become substantially greener. CWS can assist industries in these admirable goals. Reducing their water footprint can propel a company a long way toward sustainability. Facility water balances, evaluating processes to reduce water use, looking at water sources within the facility for other purposes, and additional water treatment for improved water quality for specific water needs are all ways that CWS can help your company make a difference. High-purity water systems. The majority of natural waters are not suitable for potable uses. Most municipalities or other entities provide some level of treatment prior to distribution to make the water suitable for consumptive purposes. Often, this potable water is not of a quality required for many industrial and most research applications. Additional treatment is required for the water to meet certain quality criteria. Many industries and organizations have established water quality specifications. Many of these include College of American Pathologists, National Committee for Clinical Laboratory Standards, American Society for Testing and Materials, United States Pharmacopoeia, Semiconductor Equipment and Materials International, Association for the Advancement of Medical Instrumentation. CWS can design systems to handle the unique challenges of high purity and ultrapure water systems. Components of these systems can include filtration by multimedia and granular activated carbon, first and second pass reverse osmosis, electro-deionization, mixed bed ion exchange, and ultraviolet disinfection or radiation for total organic carbon destruction. CWS has the expertise to provide these systems designed for specific needs of the client and the level of water quality required.